Hello and welcome. If you are a software tester, a QA engineer, or an SDET, you are in the right place. You are the guardians of quality, the experts who ensure that applications work as they should. You probably spend a good part of your day writing, running, and maintaining automated tests, and there's a good chance that you are using JavaScript for doing it. JavaScript is powerful and flexible, but let us be honest, it can sometimes be a source of frustration. For example, have you ever spent an hour debugging a failing test in the CI pipeline only to find that the root cause was a simple typo in a property name? Or maybe you have encountered a test that passes locally but fails intermittently in the test run, all because of a subtle data type issue. Consider the classic JavaScript scenario. You have a function that is supposed to add two numbers, but if the input accidentally comes from a web form as strings, instead of getting 2 plus 5 equals to 7, you get string 2 plus string 5 equals to 2, 5. This is a perfect example of a type coercion bug. In test automation, this could mean an assertion unexpectedly passing or failing. This could lead to a flaky test that erodes your team's confidence in the entire test suite. These small, seemingly trivial errors accumulate, leading to significant time spent on debugging rather than on creating new, highly valuable tests. And this is where TypeScript comes in. Just a quick interjection about my Udemy course. I am teaching a course about Playwright and TypeScript on Udemy. Please check it out. I have done a lot of work on that. It took me months to create the course. I have also created a companion website to go along with the course so that I could explain all the concepts shown in the course clearly. So if you have any questions, I will also be available to answer you. Let us continue with the video. Thank you. Let me introduce you to TypeScript first of all. Consider TypeScript as JavaScript with a powerful set of safety nets and superpowers. It is a superset of JavaScript, which means that any valid JavaScript code is already valid TypeScript code. You don't have to throw away your existing knowledge, you get to build on top of it. The fundamental change TypeScript introduces is a shift from detection to prevention. Instead of finding bugs in your test scripts when they fail at runtime, TypeScript helps you to prevent them from being written in the first place. It does this by adding a static type system, allowing a compiler to perform a pre-flight check on your code before it ever runs. This means that we are not just testing for quality, we are engineering quality into our test suite from the very first line of code. This proactive approach catches an estimated 15% of common bugs at the compile stage, saving you invaluable time and cognitive load. Throughout this video, we'll explore how TypeScript delivers on three core promises for software testers. Please make sure that you watch this video completely. So, I was saying that throughout this video, we'll explore how TypeScript delivers into three core promises for software testers. Number one is reliability. We'll see how to catch bugs before you run even a single test, leading to more stable and trustworthy automation suites. Number two is reliability. We'll learn how TypeScript makes your test code self-documenting, easier to read, and safer to refactor as your application evolves. And number three is productivity. we'll discover how superior tooling like intelligent auto-completion and code navigation can help you write tests faster and with greater confidence. So the three benefits of TypeScript are reliability, maintainability, and productivity, and it is a superset of JavaScript. Any valid JavaScript code is also a valid TypeScript code. To put it simply, here is how TypeScript changes the game for testers. By the end of this hour, you will have the foundational knowledge to start applying TypeScript to your own testing projects, making your test automation much more robust, maintainable, and effective. So let us get started. First things first, let us get our development environment set up. It is quick and straightforward. You will need three things installed on your machine. First is Node.js and npm. Node.js is the runtime environment that executes JavaScript and TypeScript code outside of a browser. npm, or the Node Package Manager, comes bundled with Node.js, and it is used to manage project dependencies. You can download Node.js from the project's website. It is free and it is easily available. Download it and install it, and then you will also need a code editor. I'll be using Visual Studio Code or VS Code because it has a fantastic built-in support for TypeScript, and it is also completely free. Now let us start by creating a new project folder from the terminal. You can do the same operation from Windows Explorer or using the UI. I have created a new folder and then I have changed directory and went inside the folder. After this, we will need to initialize a new Node.js project. This command, which I am going to show you, is going to create a package.json file which acts as the manifest of our project, tracking scripts, dependencies, and other metadata. The command is npm init-y. npm, as you must remember, is Node Package Manager, which comes built in with Node.js. npm init-y is the command, and I will hit enter. Now if you see the project directory, you can see that a package.json file has been created, and the contents of this file are already printed on the command line. The -y flag just accepts all the default prompts, and now we need to install the TypeScript itself. We will install the TypeScript as a development dependency because it is a tool that we use during development to compile our code, not something that the final application needs to run. This is the fine point. TypeScript is something, it is a tool that we use during development to compile our code, not something that the final application needs to run. So now I will install the TypeScript. The command is npm install TypeScript --save-dev. Now hit enter. This can take some time depending on your internet speed. After installing the TypeScript, you need to initialize the TypeScript. We are going to create a configuration file for the TypeScript compiler. This file will be called tsconfig.json, and we can generate a default version of tsconfig.json with a very simple command, npx space tsc space --init. And here you see we got the tsconfig.json. We can print this file to the command line like this, and you can see that a file with a whole bunch of JSON has been created for us. These are the default TypeScript options. Let me open the tsconfig.json in VS Code so that you can see it in a better way. I will type the command code and space and a dot to open the current folder in VS Code. Let us take a quick glance at the tsconfig.json which was generated for us. You can see that we have the target value over here. It is currently set to ESNext. It stands for ECMAScript next, and it tells TypeScript to use the latest JavaScript features that are supported by the current TypeScript version. And then we have the module common.js. This specifies the module system. Common.js or common.js is the standard for node.js, which is the foundation of most modern test runners like Playwright, Cypress, and Jest. Please note that maybe in the future these values will be different, and in that case I would advise you to look these values up in the Google or maybe ChatGPT. And then we have the root directory and out directory over here. The root directory and out directory are sometimes commented by default, and you have to remove the double / from the beginning of the line to enable these. The current root directory is ./src, which stands for source, and we'll keep all our TypeScript test files organized in a source folder named src, and .dist is the folder which is used when TypeScript compiles our code. It is going to place the resulting JavaScript files in a dist folder, this dist folder for distribution. This is going to keep our project structure neat and clean. And we also have the strict over here. This is very important. Strict is arguably the most important setting. It enables all of TypeScript's strict type checking options, giving us the maximum level of safety. You should always start your projects with the strict set to true. Now that our environment is configured, let us write, compile, and run our first piece of TypeScript code. Let us create the src directory and then a file inside it called index.ts. Inside the file index.ts, let us start by writing a simple function. Over here, notice the :string annotation after the name parameter. This is our very first taste of TypeScript syntax. It explicitly tells TypeScript that the name parameter must be a string. Please remember that JavaScript does not have such things. If you want to see TypeScript in action, I'm going to show you how it works, but first of all, let us open the terminal and let us run the TypeScript. I will say npx space tsc and hit enter. You can see that the dist directory was created automatically and it now contains some file. If we want to break this code, we can simply try to supply it a numerical value, save it, and you can see there is already a red squiggly saying that something is wrong with our code, and if we try to compile it with TypeScript, we are going to get an error. Let me remove this piece of code from here, and if we run the same type command again, the TypeScript command again, npx space tsc, it is going to compile our code into JavaScript, and we will be able to see the output in the dist directory. Over here, if you see the index.js file, you see that there is something very interesting. First of all, the type annotation which we had in TypeScript is gone, and TypeScript has done its job of type checking and then erase the types to produce clean and standard JavaScript that can run almost anywhere. Finally, we can run the code which we have compiled using a simple command, that is node space dist /index.js, and hit enter. Here you see that the JavaScript has executed. Every programming language has its fundamental data types, and TypeScript is no different. The most common data types used in TypeScript are known as the primitives, and these are string, number, and boolean. When we declare a variable, we can use type annotations to be explicit about the declared variable's type. An example is shown on the screen. Over here, the test framework variable has got the type string, and its value, the default value, will be the word Playwright. The variable test cases is a number. The type comes right after the colon, and the default value of number is 150, and the variable is passing is boolean, and its default value will be true. One of TypeScript's best features is type inference. In many cases, you don't need to write out the type because TypeScript is smart enough to figure out the types from the value which you assign to a variable. For example, let me comment the variables which I already defined and show you a different way of doing the same without the extra verbiage like string, number, and boolean. So over here, in this case, TypeScript is going to use inference and make sure that that variable test framework is considered to be a string, the test cases will be a number, and the is passing will be boolean. This functionality keeps your code clean and concise. A good rule of thumb is to only add a type annotation when TypeScript cannot infer the type, or when you want to be extra explicit for clarity. Now, what happens when you're migrating an existing JavaScript project or working with a third-party library that does not have types? For these difficult situations, TypeScript provides an escape hatch. It is called the any type or the any. For example, let me show you something. I will add some code over here. The type any over here essentially tells the compiler that trust me bro, I know what I'm doing. And it turns off all type checking for that specific variable. For example, the legacy test data over here will be treated lightly. While the any keyword is useful for gradual adoption, the goal should always be to replace the any keyword with more specific types whenever possible, because any undermines the safety benefits provided by TypeScript. As testers, we constantly work with collections of data. TypeScript gives us two powerful ways to handle this. That is arrays and tuples. Arrays are for list of items where every item has the same type. For example, a list of browsers to run our tests against, or a set of user IDs for data-driven testing. You can define an array type in two ways. The first is the type way, which is the most common. Let me show you how to do it. In this case, we have defined an array of strings which is called browsers. We can also define numeric arrays using the same technique, which is as following. We can also use Playwright's Inference and do away with the words string array and number array over here. For example, let me comment this code and show you how TypeScript's type inference can be used for defining arrays also. This is how we simplify defining an array of strings, and this is how we define an array of numbers in a simple way with slightly less verbiage. So the two statements given above map directly to the two statements given below. You can use one of these when you are defining arrays. There is another way for defining arrays as well, and we can use a generic type, array of type, for defining arrays of strings. Let me show you how to do this. For example, we cannot have duplicate variable names here, so I can call it browsers2, and this is same like the one browsers array given above, but this one is using a generic array syntax. Let's talk about tuples. Tuples, on the other hand, look like arrays, but they are used for different purposes. A tuple is an array with a fixed length and known data types at each specific position. These are perfect for representing a single piece of structured data, like a user's credentials or a set of coordinates on a page. Here is how we define a tuple. If we try to change the sequence of data as shown in the last line, it is going to cause an error, and this is going to basically provide us some security against type mismatches. Here, TypeScript enforces that the first element must be a string, the second has to be a string, and the third has to be a boolean. This rigidity is a feature, it is not a bug, as it ensures that the data structure is always correct. Choosing between an array and a tuple can be confusing at first, so here is a simple guide for common testing scenarios. The use case is a list of test users for data-driven testing. The recommended type will be array of strings. The list can have any number of users, but they are all the same types, so we don't need to have different types here. Another use case is representing a single user's credentials. In this case, the structure is fixed. There are exactly two elements, both are strings in a specific order, which means we can use a tuple over here. Then there is a set of API response codes which we need to validate. In this case, there will be a list of numbers because the length can vary. And last use case is storing a coordinate pair X, Y for a UI click. In this case, the order and the types both are meaningful. They must be same and exact and fixed. In this case, we should use tuple. Our test data is rarely just simple strings or numbers or booleans. We often deal with complex objects like profiles, API responses, or configuration settings. TypeScript excels at modeling these structures. The most common way to define the shape or the sketch of an object or a class of an object is with a type alias. We use the type keyword to create a reusable name for a type structure. Let me show you the code first. If we want to create an object according to the user profile sketch or the user profile object map, here is how we do it. We create a constant, provide it a name, add a colon, and then in the place of string or object or boolean, we specify this user profile which we have defined above this point in code or in another file from where we could export it. This is the map. This is the sketch of an object or a type which is defined by the type keyword, and down here we have the object created using that type. So by creating the user profile type, we have established a contract that any variable which is declared as a user profile must have these four properties with the correct types. For example, if you try to create this test user object and if you misspell the username over here, if you misspell this username and you use a capital N over here, you see a squiggly has appeared. These things don't happen in the old style JavaScript. Or let us suppose if you provide a string for the ID value, in that case also you will get a squiggly, and that is an error. And if you try to compile this using the TSC, you will also get a failure. We are using Visual Studio Code, that is why we are getting hints about this error. Otherwise you will get a hint in the runtime at least. Alright, you see you got an error on line number 49 and we have to fix it. It says object in literal may only specify known properties, but username with a capital N does not exist in type user profile. Did you mean to write username in all small? So this is the beauty of TypeScript. It protects you from type related mistakes. And you might also hear about interfaces. For our purpose as testers, the type and the interface are very, very similar. The general community advice is this: start with type. Start with type. It is more flexible and it can handle more situations. You can typically only reach for the interface if you are doing advanced object-oriented programming like extending classes in a large framework. One of the most powerful features the type aliases gives us is the ability to create union types using the pipe character. A union type allows a variable to be one of several types, much like a chameleon, a shapeshifter, I would say. Let me share some code over here. So here we have union types, and a very practical use case in UI testing is handling the elements that might not exist on the page. For example, a query selector in the browser returns either an element or a null. By typing our variable correctly, the TypeScript forces us to handle the null case, preventing the infamous cannot read properties of null error. Since we don't have the document defined over here, it is a very simple JavaScript or TypeScript file. So this stuff is not going to execute the way it is. So let us proceed without it. And there is another showstopper. If you try to run the JavaScript generated by this TypeScript file, that would be over here on line number 21. I have commented it, the console.log legacy test data.non-existent property. This will crash at runtime. This means that the TypeScript generated by the JavaScript generated by this TypeScript is not going to execute on the runtime. So I have commented that, and I would like to comment this one too, because this one is also going to cause problems. But I just wanted you to show that a TypeScript can be very helpful in scenarios like this. And there is a little explanation pending from the union types. Union types are more somewhat like enumerations, and because these variables can have only, if you define a type of a union type, a variable of a union type, it is going to have only a specific set of values. It cannot have any value. For example, this test result over here can be either pass, fail, or skipped. It cannot be ABCD. So if you try to give it anything else, for example, if you try to give it this error over here, it is already showing you that this test result cannot accept the string error as a value. So this also helps us against a lot of errors. Let us talk about creating reusable logic with type functions. Good test automation relies on well-structured and reusable helper functions. For logging in, for creating test data, for cleaning up the environment, and so on, helper functions make our lives easier. TypeScript allows us to make helper functions or any functions incredibly robust by typing their parameters and return values. Let us create a function to generate a test user first of all. By adding types, we will create a clear contract for what this function needs and what it will provide. Let me show you the code. You have already seen the user profile. Now I am going to bring in, so I have this function, create test user function. It has got an ID, a number, ID number, and a username string, and it returns a user profile. The user profile, which is defined up here, right here. Here we have the user profile. So that user profile is going to be returned when this method is going to be called. It is a create test user method, and we have done this below over here. So the signature of this method, this part is called the signature. So the signature of the method tells us three things. The function requires a number as its first argument, it requires a string as its second argument, and it guarantees that it will return an object that matches the shape of the user profile which was defined up here. If a function does not return a value like a setup or teardown script, we use the void return type. For example, we can have something like this over here. Since this function does not take any parameters, it is just a cleanup database function, it does not return any values, so we specify void over here, and we can leave these left bracket, right bracket empty. This explicitness makes our test suite's helper utilities predictable and prevents bugs from propagating from one part of the code to another. Just a few minutes ago, I talked about union types over here, and I mentioned the word enums briefly. But union types are not exactly enums. Enum or enumerations are a first-class citizen of TypeScript, and we can manage constants with enums. One common anti-pattern in test automation is the use of magic strings or magic numbers. These are raw strings or number values which are scattered throughout the code that have special magic meaning. Let me show you an example for example. So like here you have this function run test which takes an environment string, and this string staging over here, is a magic string. So if the environment is staging, then something specific will happen. If it is production, then something else will happen. And if the user passes in staging with a wrong spelling, they won't know what hit them until the CI says everything has failed. So this code is brittle. A simple typo in the string like stging staging won't be caught by JavaScript. The test might silently fail, or worst case, it may run against the wrong environment, like maybe production environment. Dangerous scenario. So TypeScript provides a perfect solution for this: Enums. An enum or an enumeration is a way to define a set of named constants. Let us refactor our example using a string enum, which is generally recommended for its readability in logs and debugging. I'm going to remove the function that we already have here, and I'm going to bring in my TypeScript. Alright, so now we have the enum keyword. It defines an environment which can have values staging, production and local, and if we want to call this function run tests, which is using the environment enum as a parameter, we will need to supply a value from the environment.staging, and we cannot supply a wrong value. For example, we cannot say run tests environment.stging. This is not going to fly. It is giving an error before it reaches CI or before it deletes your production data. By using the environment.staging over here, we get three major benefits. First of all, there is autocomplete. The editor will suggest using staging, production or local. As you can see here, if I type environment and control space, it shows us the possible values of this string. So this gets rid of the magic string. So you don't have to remember the exact strings. And there is also a typo prevention, which I showed earlier. And then there is readability and maintainability. The code is much clearer about its intent. If you ever need to change the underlying string values, for example from staging to stg-server, you only have to change it in one place, in the enum definition over here. You don't have to change it everywhere. So enums are a fantastic thing for representing any fixed set of options in your tests, such as user roles, browser types or application states. And this is it for technically the part 2, but we are going to continue in this video. This is one giant video. It has to be about 1 hour long. So the next thing we are going to talk about is the TypeScript in action for real world testing scenarios. So see you in the next one. Just let the video play. You don't have to do anything. Now let us put these concepts into practice. A huge part of modern testing is API validation. We'll write a simple test to fetch data from a public API and see how TypeScript protects us. First of all, let us define the shape of the data that we expect from the API. We'll use the JSON placeholder API, which provides fake data for testing. We'll fetch a post object. So let us see. Let me first of all define this thing over here like this. So here we have defined a type which is called post. Now let us write an async function that fetches post and validates its structure. For this example, we'll use just a simple console.assert for our check. I'm not typing code because that is going to be like a lot of boring drudgery. like most of this video is. You have to do what you have to do. Okay, so this is the test fetch post. It is fetching some values from the JSON placeholder API, and this code perfectly works. But right now let us simulate a common scenario that the API contract changes. But before we do that, let me quickly run the TSC and call this method. This method is called here. So let me quickly run the TypeScript compiler and then show you what happens if we run this code. Okay, so it has worked fine. I did not save the file. So when you make changes to your TypeScript files, you must save them before you run the npx tsc on them. That's a blooper right there, but I will include it in the video. Okay, and now I can run the JavaScript. You see, we have gotten the data and the API test has passed. So I was saying that this code works perfectly, but let us simulate a common scenario that the API contract changes, like that something changed on the server. Let us say that the development team renamed the title to post title. In the API response, this code works perfectly, but now let us simulate a common scenario. The API contract changes. Let us say that the development team renames the title to post title in the API response without telling you or without documenting. So in a JavaScript test, you would not know this until your test failed at the runtime. But with TypeScript, watch what happens. We only need to update our definition to reflect the new contract. We will change it over here and everything should be fine. So the instant we make this change, our test function is going to say something about it. Over here it says that the type of post title is not cool. Alright, here's the red squiggly. So VS Code immediately puts a red line under the post.title and it gives us an error that the property title does not exist in our type post. Did you mean post title? This is the core value proposition of TypeScript for testers. The compiler, acting as an automatic specification checker, has just detected a mismatch between our test's expectation and the API's contract before we even saved the file. Although you should save your files after changes. So we have not run the test, but we know that there is a problem in the API contract. So this direct link between your type definitions and your test code is a game changer for maintaining API testing suites. For UI testing, the page object model, POM or POM for short, is a widely adopted design pattern. It can be used with Playwright, WebDriver IO or Cypress, or any other UI testing framework. POM makes our tests much more maintainable. It allows us to keep the code related to different operations performed on different pages in separate files, and it reduces rewriting a lot of code. Let us see how we can create a POM in TypeScript, and we are going to use a fictional login page. And first of all, we are going to create a credentials type and we are going to store it in a separate file. I will create a new file, types.ts. over here. I am creating it in the source folder for sake of simplicity, and I will paste the code over here. So it is a very simple type, a very simple class which contains just a username and a password. And in order to use this guy, I'm going to create another new class, another new TypeScript file. I will call it login page.ts. Now login page.ts is going to contain a full class instead of just a type. Now you may ask why we are using class over here instead of type. So basically type is related to TypeScript and class is a different thing. They are similar in some senses, but going in depth in the differences over here is going to be a little too much. So I am not going to go in depth over here. So in short, class serves a different purpose and it has got a lot of differences from type. So a type is for TypeScript only, and on the runtime the types don't exist but the classes do exist. So it might sound confusing, so just please don't be confused. Maybe I could do a quick fix. Use import type credentials. Okay, so there is a difference in syntax over here apparently, which was not present previously. So we have to import it like this. In this case, import type credentials from this types file. So now we have this type credentials available over here. And next what we can do is that if you see that our login method, we have another error down here. Let us see what is the fix. Top level export modifier cannot be used on value declarations in common JS module with verbatim module since. So okay, so please fix it. Alright, so this is a small problem which was easily fixed by GitHub Copilot for us. So we can create an object here and then we can export it. A little difference of syntax, but I believe you get the point. So this is how we can create a type separately, and then we can have a class which could perform different operations. We could use it with WebDriver IO, we can use it with Cypress or Playwright. We just need to pass the appropriate page over here. Since we don't have the page objects over here, we are simply just using console.log to simulate or mimic the UI operations. Alright, so you can notice that our login method takes one argument, that is creds, which is explicitly typed as credentials over here. So creds is a credentials which is defined in the types.ts. This creates a strict contract. Now let us look at our test file where we use this page object. For example, and let me create a test file over here. Again, please bear with me, I am just trying to explain something. .test.ts. Ideally speaking, this test should not be here, but let us just never mind. So we have this login page guy over here, and again we have some problems with the import syntax. Type credentials from types, and for this we will have to do something different most likely. Import login page equals to required login page, or by turning on the module interrupt flag and using the default import, or we will go with whatever. So this was suggested by Gemini. Okay, go ahead, do it. So now we have the login page over here. Basically we got this login page which essentially encapsulates the functionality of this entire class, and now we can use it very simply. Always remember to save your files. Alright, so the idea here is that if we create an instance of the credentials over here, we supply it a username and a password, and if we try to call the login page.login over here with valid credentials, it is going to work just like this. But if we try to call the login page .login with invalid credentials. For example, instead of supplying the username and password, I have given a user and pass over here. We are going to get an error like, for example, login page .login, and if we do invalid credentials here, because we are using TypeScript, this error was caught here, and this problem has been diagnosed before it could become a serious problem. This demonstrates how TypeScript enforces the contracts between your test logic and your page objects. So it makes your entire UI testing suite much more robust, easier to read, and significantly less prone to simple data related errors. By using TypeScript with classes and types, QA engineers are engaging in the same software engineering practices as developers, using the same language features and design patterns. The shared context helps break down silos, it makes code reviews more effective, and it elevates the role of the tester to a true engineering partner. Please note that I am also teaching a course on Udemy which is about Playwright test automation in TypeScript. The link to the course is given in the description. Please click on that link and do check out my course. So I was saying that we have seen how TypeScript gives us feedback in the editor, but we can take this one step further. We can check our entire test suite for type errors within seconds without launching a browser or making any API call. This is done with a simple command that tells the TypeScript compiler to only perform type checking, not to generate any JavaScript output files. The command option --noEmit means that the TypeScript compiler is going to only perform type checking and it is not going to generate any JavaScript, and it is a very fast operation. For example, let me show you on my screen npx tsc --noEmit. npx tsc. npx is node package executioner or executor. It is a sister or a brother of node package manager. So npx tsc --noEmit with a capital E. So running this command can be considered like a static test passing for your automation code. It is an incredibly fast and efficient way to validate the structural integrity of your entire testing suite. If you have refactored a page object, or if an API type has changed, this one command will instantly tell you every single place in your test suite that needs to be updated. For maximum benefit, this command can be integrated into a pre-commit hook. This would prevent any code with type errors from ever being checked into your repositories, saving countless hours of debugging failed CI/CD pipelines and ensuring a baseline of quality for your test code itself. We have covered a lot of ground in the last hour or so, and it shows your commitment towards learning. We started with the common frustrations of dynamic JavaScript in testing, and we saw how TypeScript provides a powerful solution. We set up a project from scratch. We explored the core concepts of types, arrays, objects and functions, and enums, and then we applied these concepts to real-world API and UI testing scenarios. The key benefits we have demonstrated are clear. Number one, there were fewer bugs. By catching type-related errors in the editor, you eliminated a whole class of bugs before they ever made it to the test run. Then there was easier maintenance. With self-documenting code and safe refactoring, your test suite becomes easier to manage and scale as your applications grow. Third was better collaboration. You are using the same language and same tooling as your development team, fostering a shared understanding and improving communication. And last but not least, my rooster won't let it go. Last but not least, faster development means intelligent auto-completion and instant error feedback from the IDE means you spend less time looking up documentation and more time writing effective tests. In fact, you saw that I got stuck in a few places during the course of this video, and I was able to quickly resolve the issues using GitHub Copilot. I can tell you with confidence that this could have taken many hours to resolve about 5 or 7 years ago, before AI was mainstream. I have seen those times. So if you are feeling inspired and if you want to get started, here is my advice. Go check my course on Udemy. Yes, on a serious note, do check my course on Udemy. It is about Playwright. I have done a lot of hard work for that. There is also a demo site that comes with the course, specifically made for the course. So I have tried my level best to explain everything really well. So first of all, the advice is that, second advice is that you don't need to convert your entire JavaScript project into TypeScript overnight. A great first step is to pick an existing JavaScript test file in your project, rename it from .js to .ts, and then start adding types. You will begin to see the benefits almost immediately. Modern test automation frameworks like Playwright and Cypress and even WebDriver.io have excellent first-class support for, this line I'm not sure about. I would say modern test automation frameworks like Playwright and Cypress have excellent first-class support for TypeScript, making the integration seamless. So I will leave the links to the official documentation in the description below. And thank you very much for joining me today. I hope this introduction has shown you how TypeScript can be a true superpower for your test automation efforts. If this video helped you, please give it a thumbs up, share it with your friends, subscribe to this channel for more such content on software quality and testing. I am planning to make many more videos about software technologies like PyTest, in test automation, WebDriver.io, Cypress, and much more. And do check my courses on Udemy and let me know in the comments what you would like to learn about next. I would love to make new videos for you. Thank you very much. Happy testing. Bye.